year is 1519. A Spanish soldier named Bernal Diaz del Castillo stands on the causeway of Iztapalapa at sunrise, looking across 7 kilometers of lake water at a city floating on the surface. 200,000 people live there. 3 causeways, 2 aqueducts, a 16-kilometer dike, a pyramid 60 meters tall, all of it built without iron, without the wheel for transport, without a single horse, mule, or ox. Bernal Diaz writes that he thought he was dreaming. How did the Mexica build the largest city in the Western world without the 3 things every modern engineer would call essential? Subscribe if you want to know how they did it. Start with the problem. In 1325, a small group of Nahua-speaking refugees called the Mexica arrived at the western edge of Lake Texcoco. They had been driven out of every previous settlement they had attempted across the central Mexican plateau. The only land available to them was a marshy island in the middle of a shallow, brackish lake. Uninhabitable by every reasonable standard, they had no iron. The Iron Age, which had transformed Europe and Asia for 2,000 years, had never reached the Americas. They had wooden tools, stone hammers, obsidian blades, hardened sticks for digging, and a small amount of cold-hammered copper for ornament. They had no draft animals. There were no horses in the pre-Columbian Americas, no oxen, no donkeys, no camels, no large herbivore that had been domesticated for pulling, carrying, or plowing. They knew the wheel as a concept. Pre-Columbian wheeled toys have been recovered from archaeological sites across Mesoamerica, but they had no use for it in transport because they had nothing to attach a wheel to. The Mexica arrived at their swampy island in 1325 with the technological inventory of a Neolithic civilization and were told, in effect, to build a capital city. 200 years later, that capital was larger than London, larger than Paris, larger than Seville. Hernán Cortés, in his second letter to King Charles V, written in October 1520, describes the marketplaces of Tenochtitlan as wider than those of Salamanca and busier than those of any city in Spain. He writes that he is ashamed he does not have words sufficient to describe what he saw. Europe had iron, and the Mexica had geometry. Now look at the ground. The first engineering problem the Mexica had to solve was that their island would not support stone buildings. The lake bed beneath Tenochtitlan was a layer of saturated volcanic clay so soft that a wooden stake could be pushed through it by hand. Modern geotechnical engineers would call this an unbuildable substrate. The Mexica answer was the chinampa, the so-called floating garden that most school books reduce to a quirky farming trick, and that was, in fact, the geotechnical foundation system that made the entire city possible. Each chinampa was a rectangular plot roughly 30 meters long and 2.5 meters wide. The Mexica drove vertical stakes of ahuejo, a species of willow, Salix bonplandiana, whose roots do not rot in waterlogged ground but instead grow laterally beneath the surface, into the soft lake bed at intervals of roughly 40 centimeters. They then packed the interior with alternating layers of lake mud, decomposing vegetation, fresh soil, and reeds. As the ahuejo stakes took root, the willow roots spread outward through the substrate, weaving a living lattice that grew stronger every year. Modern soil science has confirmed what the Mexica figured out by trial. The ahuejo root system creates a rhizosphere microbiome that stabilizes pH, retains nitrogen, and prevents the anaerobic decomposition that would have collapsed any inert platform built on the same substrate. The city did not float on the lake. It was anchored to the lake by living trees. By 1519, the Chinampa system covered an estimated 9,000 hectares around Tenochtitlan, supporting both the foundation of the urban core and the agricultural production that fed 200,000 people. Venice, at the same hour, was already sinking on its dead oak piles in the Adriatic lagoon. Think about what this means. The chinampa was not a clever farming technique that happened to also support the city. It was the engineering principle that made the entire civilization possible. Every street in Tenochtitlan was bordered by chinampas. Every neighborhood was floored on chinampas. Every temple platform was built on consolidated chinampa land. The city was not built next to the agricultural system. The city was the agricultural system, scaled vertically. Modern soil engineers studying pre-conquest chinampa cores have found that the layered stratigraphy, alternating mud, vegetation, soil, and ash, produced a substrate with compressive strength comparable to compacted modern fill, but with one critical advantage. The living root network kept growing throughout the lifetime of the structure. So the platform got stronger every year rather than weaker. A modern foundation begins degrading the day it is poured. A chinampa foundation reinforced itself every season for 200 years. Mexico City, the modern capital built on the drain bed of Lake Texcoco, sinks today at a rate of approximately 25 centimeters per year in some districts, a rate that has destroyed colonial cathedrals, broken aqueducts, and continues to cost the modern Mexican state billions of pesos in damage repair. Tenochtitlan, built on the same lake bed by people without iron, did not sink. Venice put dead wood in the mud. Mexico planted living trees. If this is the kind of history you come here for, a like genuinely helps. Here is where the system reveals its real intelligence. The Mexica did not have draft animals or wheels, so they had to solve the problem of moving stone and timber across a city built on water using only two transport mechanisms, the human back and the canoe. They solved it through the most disciplined labor organization in pre-modern history. The Codex Mendoza documents the coediquidal, the rotating labor obligation that bound every adult male in the empire to a documented number of days of public service per year. The work was assigned by the Calpixqui, the overseer, and supervised by the Tlaquilo, the architect-designer who held a position in the Mexica social hierarchy, roughly equivalent to a senior engineer in a modern public works ministry. The Tamims, the human porter class, carried building materials across distances modern logistics would consider impossible. A standard Tamimi load was 23 kilograms, the Mesoamerican equivalent of 2 arrobas, and the standard daily march was approximately 30 kilometers. Larger blocks moved by relay teams. The basalt, andesite, and limestone for the temples came from quarries in the surrounding mountains, some as far as 40 kilometers from the construction sites. The blocks were rough cut at the quarry with stone hammers and obsidian wedges, transported by Tamim relay teams to the lake edge, and then loaded onto canoes that crossed the lake network and unloaded at the destination. The canoes themselves were dugouts carved from single trunks of ahuet cypress, capable of carrying loads of up to a metric ton, paddled by crews of 4. The Florentine Codex documents that the canal network of Tenochtitlan was specifically designed to allow this material transport system to reach every neighborhood without crossing dry ground. The city was, in effect, a logistics machine. Every street had a parallel canal, every neighborhood had a dock, every public works project had a supply line that ran from quarry to canoe to canal to construction site without ever requiring a wheel or a hoof. And here is the calculation that makes this system so impressive. A Roman ox cart of the imperial period could carry approximately 500 kilograms of stone at a top speed of 3 kilometers per hour, requiring the maintenance of 2 animals, fodder, water, road infrastructure, and a driver. A Mexica dugout canoe of standard size carried approximately 1 metric ton, twice the load at 4 to 6 kilometers per hour, paddled by 4 men who returned to other public works at the end of the shift, required no fodder, no road, and no animal husbandry. The canal network of Tenochtitlan, mapped by archaeologists from the Templo Mayor project and reconstructed from colonial era maps including the famous Plano de Maguey, contained at least 25 primary canals and hundreds of secondary channels. Every neighborhood of the city was within 100 meters of navigable water. The marketplace at Tlatelolco, which Cortés in his second letter described as larger and busier than the Great Square of Salamanca, and serving roughly 60,000 customers a day, received almost all of its goods by canoe. The food, the stone, the firewood, the human waste collected for Chinampa fertilizer, the building materials, the tribute from outlying provinces, every kilogram of mass that entered or left the city traveled by water at a fraction of the cost of land transport in any contemporary European economy. The absence of the wheel was not a deficiency. It was a feature of a logistical system specifically optimized for a city built on a lake. Rome needed horses, Mexico needed canoes. Now look at what they built with it. The 3 causeways of Tenochtitlan were not roads in the modern sense. They were engineered embankments roughly 8 meters wide, surfaced with packed earth and crushed limestone, anchored on driven pile foundations, and equipped with removable wooden bridges at strategic intervals so the city could be cut off from the mainland during military emergencies. The causeway of Iztapalapa, the one Bernal Diaz first walked on in November 1519, ran approximately 7 kilometers from the southern shore to the central plaza. The causeway of Tlacopan, the western route, ran approximately 3 kilometers. The causeway of Tepeyac, the northern route, ran approximately 5 kilometers. Cortés in his second letter describes these causeways as wide enough for 10 horsemen to ride abreast, a measurement that probably reflects 4 horsemen given the standard inflation of conquistador prose, but which is corroborated by modern archaeological excavations that confirm that causeways were among the largest engineered structures in the pre-conquest Americas. Running parallel to the Tlacopan Causeway were the 2 aqueducts of Chapultepec, completed around 1466 under the direction of the Texcocan king and engineer-poet Nezahualcóyotl. The aqueducts carried fresh spring water from the hills of Chapultepec, 4 kilometers across the lake, directly into the city center. The system was redundant by design. When one aqueduct was closed for maintenance, the other carried the full load, and separating the brackish eastern half of Lake Texcoco from the fresher western basin where the city sat was the Albarradán de Nezahualcóyotl, a 16-kilometer hydraulic dike completed around 1450, also directed by Nezahualcóyotl, equipped with sluice gates that allowed controlled water exchange between the two basins and regulated salinity. Water level and flood risk with a precision modern hydrologists have compared to a primitive but effective desalination membrane. And here is the detail that elevates the engineering beyond admirable into the territory of remarkable. The removable bridges along the 3 causeways were not symbolic. They were the city's primary defensive feature. The Mexica had figured out, by observation across 2 centuries of intercity warfare on the Central Plateau, that a defensive wall is a one-time investment that can be breached or scaled, while a removable bridge is a renewable defensive system that turns the city into an island on demand. When the Western Causeway needed defense, the bridges were pulled. The city became unreachable except by canoe, and the Mexica controlled every canoe on the lake. The strategy nearly worked during the conquest. Cortés, in his account of the famous Noche Triste of June 1520, when his army was driven out of Tenochtitlan under cover of darkness, describes the catastrophic moment when his men reached an open bridgeless gap in the causeway and had to choose between drowning under the weight of their armor and turning to face the pursuing Mexica. 600 Spaniards died at that gap. The bridges were doing exactly what the engineers had built them to do, 4 generations before any Spaniard set foot on the causeway. London in 1519 had 1 stone bridge across the Thames. Tenochtitlan had 3 causeways, 2 aqueducts, and a 16-kilometer dike. And then there is the Templo Mayor, the structure that more than any other defies the modern assumption that you need iron, wheels, and draft animals to move stone. The pyramid was built in 7 superimposed phases between approximately 1325 and 1487, each phase enclosing the previous one inside a larger envelope of cut stone. The final structure measured approximately 80 meters on each side at the base and rose 60 meters above the plaza. Modern archaeological excavations conducted by the Templo Mayor project, directed since 1978 by Eduardo Matos Moctezuma and currently led by Leonardo Lopez Lujan, have documented every phase of construction, recovered tens of thousands of offerings from inside the structure, and quantified the labor inputs required. The estimates are staggering. The final phase of the Templo Mayor required the cutting, transport, and placement of millions of tons of basalt, andesite, horizontal volcanic stone, and lime mortar. The work was completed without iron chisels, without pulleys, without cranes, without wheels, without horses. It was completed by the Coatiquill labor system applied across 2 centuries of empire, organized into seasonal work cycles aligned with the agricultural calendar. So the same workforce that built the temple in winter planted the chinampas in spring. The Spaniards who arrived in 1519 spent 2 years trying to destroy what the Mexica had spent 200 years building. And even after the demolition, the foundation of the Templo Mayor remained intact beneath the colonial cathedral they built on top of it. And what they buried inside those 7 phases is, in its own way, more telling than the engineering itself. The Templo Mayor project under Lopez Lujan has so far recovered more than 200 ritual offerings sealed within the pyramid's interior. Caches of jade carved from sources hundreds of kilometers away, ceramic vessels from the Pacific coast, gold from the Mixteca, copper bells from the Tarascan kingdom, obsidian blades from Pachuca, jaguar pelts from the Yucatan, marine shells from both the Atlantic and Pacific. The construction of the pyramid required not just the labor of the Mexica directly. It required a continental trade network that pulled offerings into the temple from every corner of Mesoamerica, integrated through tribute relationships, marriage alliances, and merchant guilds. The Templo Mayor was not just an engineering project. It was the physical manifestation of a multi-state political and economic system that operated at its peak across roughly 200,000 square kilometers of central and southern Mexico, and that managed all of it without a written alphabet in the European sense, without printed records, without wheeled transport, without iron metallurgy. The administrative apparatus that built the pyramid was as advanced as the engineering that designed it. Modern New York needs cranes. Tenochtitlan needed organization. Hollywood will tell you that pre-Columbian civilizations were primitive, technologically limited and dependent on superstition. The actual archaeological record, the Florentine Codex, the Codex Mendoza, Templo Mayor project under Matos Moctezuma and Lopez Lujan, the engineering reconstructions published by UNAM over the last 40 years, says something the textbooks softened to keep the conquest narrative tidy. The Mexica built, between 1325 and 1519, the largest city in the Western Hemisphere on a surface that no modern civil engineer would attempt to develop without geotechnical reinforcement, hydraulic modeling, and a billion-dollar contract. They did it with stone tools, human porters, willow roots, and the most sophisticated public works labor system anywhere on Earth. They did not invent the wheel for transport because they did not need it. They had the canoe, which carried 10 times the load of a horse cart at a fraction of the maintenance. They did not domesticate large draft animals because their continent did not produce species suitable for domestication after the late Pleistocene extinctions. They did not develop iron because the trade networks that would have connected them to known iron sources did not exist. And yet, working with the inventory they had, they produced engineering outcomes that exceeded contemporary European cities on almost every measurable dimension: clean water, sanitation, urban density, market scale, monumental architecture, hydraulic control, flood mitigation, sewage management. The conquest narrative requires that the Mexica be backward. The archaeological record requires that they be advanced. Both cannot be true, and the side that has the field reports, the carbon dates, and the excavated foundations is the side telling the truth. This is the lie of the wheel and the iron sword. The Mexica did not lack technology. They lacked the technology Europe had, and they had the technology Europe did not. They had agricultural systems that Europe would not reach until the 17th century. They had urban sanitation that Europe would not reach until the 19th. They had hydraulic engineering that Europe still cannot fully replicate. They had a labor coordination system that built a 60-meter pyramid through 7 superimposed phases over 162 years without industrial machinery, without a single iron tool, without a single beast of burden. The story that the conquest was a meeting between an advanced civilization and a primitive one is exactly backwards on every dimension except military steel and biological warfare. Cortés did not enter a primitive city in November 1519. He entered the most sophisticated urban system in the Western world, and within 2 years reduced it to rubble. The cathedral he built on top of it stood on a foundation his masons could not have engineered. If what brings you here is the engineering, the systems, the actual record of how a pre-modern civilization built what modern cities still struggle with, then this channel was built for you. Subscribe, and you will see what comes next. The next time you watch a construction crew arrive at a building site with a fleet of trucks, a crane, a dump truck of crushed stone, a generator, a concrete mixer, and a team of workers with steel tools, remember this. 500 years ago, on a marshy island in a shallow lake 40 kilometers from the nearest hardwood forest and 100 kilometers from the nearest serviceable quarry, a workforce of rotating peasant laborers under the direction of a single architect-engineer raised a 60-meter pyramid of cut basalt and andesite, surrounded it with a plaza paved in limestone, ran 2 aqueducts across 4 kilometers of open water to supply it with fresh drinking water, built a 16-kilometer dike to keep the city from flooding, and supported a population of 200,000 people inside the engineered envelope they had created. They did it with willow stakes, obsidian blades, dugout canoes, human backs, and a labor system that distributed the work across an entire society for 2 centuries. They did not have iron. They did not have wheels. They did not have horses. They had each other, the calendar, and a system of public works that no European city of the same era could match. They did not need the tools you assume civilization requires. Mexico City sits on top of that engineering today, and every measurable indicator says the modern city is doing it worse than the Mexica did. The colonial cathedral in the central plaza, built directly over the Templo Mayor foundation, has sunk 30 centimeters into the lake bed since its completion in 1813, and is currently supported by a steel cradle of post-tension cables installed in the 1990s to prevent collapse. The drainage of the original lake, completed by Spanish engineers over the course of 3 centuries and finalized in the early 20th century, has produced the catastrophic land subsidence that is now slowly destroying the colonial city center and threatens the urban water supply of 9 million people. The Spaniards inherited an engineered hydraulic environment that worked perfectly for 2 centuries. They drained it because they did not understand it. The original Mexica system regulated salinity, controlled flooding, supported agriculture, supplied drinking water, and accommodated transportation across an entire urban region without a single drop of imported energy. Modern replacement uses billions of kilowatt hours per year to pump water uphill from the sources hundreds of kilometers away, and it still fails during the dry season. The civilization that did not have iron, did not have the wheel, did not have a single beast of burden, built a city that worked better than the one we have built on top of it. They built civilization with the tools they had.